By the way, this was basically the hit of our booth. I mean, everybody came by to see this thing. I'd say that's the hit of our booth.
Yeah. Right. So this was my creepy head project for Maker Faire, and I brought it last month, but then forgot my remote control, so it just sat there. And so today I can show you what it looks like actually moving around. You can do left, right, up, down, and side to side. And it was very fun to go side to side because the little kids would tip their heads to match it. And then, of course...
I'm sorry, Dave. I'm afraid I can't do that.
Having to explain to the kids where that came from.
Yes, almost nobody under whatever 40 got that. So now, of course, I still need more software to be able to use the stereo microphones to turn towards the person who's speaking, and to use the camera. You can see the camera display here.
So what, the eyeballs move up and down and side to side?
Yes, I can also use the controller to move the eyes, and they're independent, so that made it nice and extra creepy as well.
High points on creepiness.
So the eyes are just ping pong balls with kitchen match stuck through it, and paper clips and hobby servos to move the paper clips and ping pong balls, and there's a Raspberry Pi spy camera inside the ping pong balls so that you get camera output.
You got 2 cameras in there?
Yeah, there's 2 cameras, which requires 2 Raspberry Pis, but I only have 1 Raspberry Pi on there because when I have the display hooked up, the cable interferes with the position of the other Raspberry Pi. So, there you have it.
You get a Jetson Nano.
Thanks very much.
Are you doing anything specific with the 2 cameras?
Am I going to go?
Well, eventually what I was planning to do was to have each eye track the same person or object, so that as they get closer, your eyes kind of cross toward inwards, and also just because
I noticed that. Yeah.
I thought it would be cool to have each eye kind of doing its independent thing. But you could also do like a stereo depth processing, that kind of thing.
Great, thanks very much.
Okay.
Maker Faire was fun. You already heard the report, but it was a great show because it was raining. Everyone was inside looking at our robots. So let's see. I guess about maybe 2, maybe 3 months ago, Steve brought in a Scamps version of this, which is the official real thing. This is a LiDAR unit mounted on top of a rotating platform with a Raspberry Pi underneath and a couple of stepper motors for rotating it, etc. The thing is making a plane of a LiDAR scan in this direction. So what you do is you hack it up, you make a custom mount for it for the Nito LiDAR X11. Little hand for Nito, yay! And then it's just a matter of software at that point. Woo! But I did make a driver that plugs into all the rest of their software and has the same interfaces and so forth. So I found out when I tried to do a scan of the room about 3 minutes ago that I don't have rubber feet on it. So as it rotates, the base also rotates, which is probably not terribly good if you're trying to make a 3D model of a room. But anyway, you can see the thing moving around here. Oh, look at that. An MIT guest from the East Coast. Very nice. Sorry about the interruption there. So if anybody wants to talk about it, I have the model for the parts here because I had to hack them up a bit to make it work with the Nito. And I have those on my Thingiverse site. So there is one part that's pretty hard to make due to the overhangs and the complexities on both sides. You have to kind of hack on it afterwards to take off support material and so forth. But if you're interested in one of these, Nito X11 LiDAR on top is a lot cheaper than the Scamps. Plus you can't really get them except for like $300 these days. So that's it. I'll let it finish. It doesn't seem to be...
How does it know what plane it's looking at?
Oh, and the coolest thing about this is the software. So it's taking a plane, like you were asking there, from the Nito, from one revolution, I have gather up one scan. Then I send it to the software, a big collection, it's all in Python, and the software knows what angle the rotation was of that plane, and then it's only a matter of math.
What sensor detects the angle?
Actually, it's a stepper motor, and so it's open loop detection of the angle. But stepper motors are really accurate as long as you don't have so much drag on them that they're going to slip. So it starts in one position, it goes to end and hits a limit switch, and then it knows that it's at the starting point, and then it continues around for how many degrees you specified, and it knows that it's 0.67 degrees or so. And it just does the math from there. So it's really open loop on knowing the rotational angle in this direction.
Yep. The other interesting thing is it's actually able to do a 360-degree scan with only 180 degrees of mechanical turn because you're doing a full.
Yeah.
Yeah. So that's kind of something I haven't seen in a lot of other like large
So
fixed
it
LiDAR scanners.
goes back and forth.
No, it just goes around.
Goes around and continues.
Because it's doing 360 degrees, and so you get
Just
the front and the back in one.
So you only need to rotate a teeny bit more than 180.
Do you have a display to show?
A what?
A display?
Yeah, so what happened is I was unable to load that on this PC because of some kind of Visual C++ library issue, and I fought with it for a while, and I said, forget it. Steve will probably come, and certainly he has. So we'll take this data off of this, which it's probably almost done. We'll take the data off of this, and if Steve's kind enough to let us run it on his version of Cloud Compare, which is free software that look at point clouds and so forth, then we can take a look at it on there. It's kind of neat. You rotate around your world, but you don't fall off. All right, thank you.
One more question.
How long does it take to do the 180 scan?
Actually, it's like just finishing now, so it's not very fast. It probably takes about 5 minutes to do that scan. And because of the distance of the LiDAR, it's not going to get the back wall. That's going to be an open void. It'll probably get this stuff here, although I've been moving around. I should have tried to stay in its shadow. If you stay out of the plane of rotation, you can be missing from the scan. Otherwise, you'll be... And that's it. So that's how long it took. When I first started, I hit enter, and that was one scan. Thank you.
Hi, everybody. I don't know if you remember me, Ken Miller, Zaz Robotics. Developed this little robot we call Zaz the Bot. It's a three-wheeled Omnibot. It's designed to play games and have fun. It really doesn't do much other than that right now. It's got modular components. As you cycle the power, the LEDs change. We also have an app that you control with your smartphone, and you can change the LEDs and drive it around. Let me see if I can get it to go here. Oh, the app is still on. Hang on. Well, never mind. We'll get it going in the back. But what I wanted to show today is some of the modules I'm working on. So there's modules that can plug in the bottom. We plug a charger in the bottom, but we also can add other modules. So this is the beginning of a module for your table challenge. So we can add sensors, and so it can sense the edge of the table and won't fall off. We can also add some more LEDs. We can add line following to this module. So this module is going to screw on the bottom. Let's see if I can get it on there. It has to be oriented right. Hang on. There we go. So that one's going to go on the bottom like that. We can also put charging board on there, so we can do inductive charging. But what I really want to show today is this. I don't know if I don't think I brought this before. I brought a different cannon that shot wiffle balls, baseballs, but this one shoots ping pong balls. So the idea is that we're going to be able to take this dome module off, and then we can install this. Let's see if I can get this one to go on. Okay, so like that. And then if you want, you can put the dome back on. This one's not wired up to through the stack to light the dome up, but eventually we'll get there. So this one, and also right now, this one isn't controlled through the app of the robot. This one is manual right now. So that's one of the things we're working on, is the electronics for this. So we have to spin up the 2 wheels, and then we're going to fire it. Oh, first time it doesn't work. Hang on, there's something jammed. It was working perfect yesterday, of course.
Got a robo jam.
Hang on, don't panic. Don't panic. Let's see. Okay. Hang on. Okay. So since the robot can turn, we can change the direction. It's not working. So then we can also adjust the angle. There's a deflector plate here, so we can straighten that. We can shoot higher. So we can shoot almost straight up. And then we can also shoot straight out. Let's see, we should be able to get this to work. Wait a minute, that's upside down. Hang on. There we go. Okay, that's it. And then we're going to play some games in the back. I brought the stadium, and so everybody afterwards can come back and we'll play some games, all right? Thank you.
Okay, Dylan?
Welcome to another episode of what Dello cobbled together like the night or so before Maker Faire. He's gonna have a robot demo. So I don't know about you, but my robots like toys. Robots like toys. At least my robots like toys. So we have some colored blocks here. We have a. So this is, some of you might actually recognize, this is the old saucer bot that I had from like 2009, 2008. It's like, the basic platform is about 10 years old. It's a Apple Airport with some Roomba wheels. And I decided that this is going to be kind of like my Maker Faire project, and I was going to hack things back together and basically rehab it, and I did. And so one thing that I noticed that's basically changed the past 10 years is I'm not using shape lock for things anymore. I'm 3D printing everything. So like in the past 10 years or so, we've been 3D printing, and then I have like I don't know if you can see this or not, but a single board on the inside there. This is a DF Robot Romeo board, and it has it's an Arduino but with a 32U Force processor, and so it also has like a dual motor controller, DC motor controller, built-in Bluetooth, built-in XB, built-in servo controller, kind of built-in everything. And this, so there actually used to be like 3 or 4 boards in here for the original one, and it has a gripper on it now. So let me just, and it has a Pixie 2 camera at the top there. So, yeah, my robot likes to collect blocks. And it likes to collect them in a specific order. So if you show it a block, and it's not in the right order, it's not what it's expecting, it kind of gives you a little head shake. Nope, nope, nope. That's not what it wants. So show it another one. No, that's not it either. Okay. So show it. There we go. So that one. And then it takes it, and it, well, kind of puts it over in its little pile. And then you show it the next one. No, that wasn't the right one. Okay. So, and then it puts it over in the pile. And this is actually this is a great hit with the kids at Maker Faire, because it's like blocks and color sorting and robots and things. The little kids just I spent like the entire weekend there just like talking to kids about the height of this table.
Yeah.
We wanted to help feed the robot. Okay, that's, yeah, still a few bucks left in the system.
Little big for the grabber.
Yeah, and then, so show it the red one. And then it does a little victory lap because it got all the blocks that it wanted and it got it in the order that it wanted. So that was my demo for Maker Faire. And we still got like the side sonars on the front and on the back. One interesting thing is that you put the block in front of it, and it senses it, and then the gripper opens up, and the way that it tells that it got the block is it looks at the little sonar sensor here and sees it if it's like right in front of it. And if it stays in front of it after it's gripped it, then it knows it actually kind of got a hold of it, and then it goes and puts it off in the pile. And if it doesn't, then it kind of goes like, makes a little motion like this at you, and says, hey, you know, give me that. So that was kind of that, and I've got side sonars, so it could do like a table bot, yeah, that's pretty much it.
So this is the Wayne bot that you all know and love, except there's something new. Alright. Testing? Okay. So this is the Wayne bot that you all know and love. It'll go to the edge of the table, notice the edge, come back, and then turn and go in some other direction. But now I have added some simple things, like a button. So you can switch between the two modes, and these little LEDs here, which indicate what the sonar sees. So it's brighter or dimmer based on how close to it something is. And the kids, I teach how to make this robot, and the kids have seemed to really like that. So I'm going to tempt fate and try switching between the two modes using the button. I was surprised that, I mean, like, I've done this sort of thing before, but I was surprised at how much of the code I needed to change in order to get a button to work. Instead of using delays and stuff, I have to, or at least the way I did it, is by having a state machine and at any time, so there's a loop, and it's always checking whether the button has been pressed. And yeah, let me put this down so I can use two hands.
Do you want, oh, never mind, you just answered my question.
Oh, okay. All right, let's see. Okay, so it's doing the turning.
Limited space.
All right, so it's detecting the edge, and then it doesn't really go forward very far, but it's detecting the edge, and then as soon as both things are over the edge, it'll back up and turn and then go in another direction. And it should be the case that at any time I can press the button and it will switch to the other mode. So I'll do that now. So I also have to change this. These go like that. the button, and I made it so that there's an LED that indicates that it saw that I pressed the button. And I'll turn the motors back on, and now it's doing this. Hooray! So the same two behaviors, but I've added the button. Thank you. Thank you. That is it.
Amazing what a button can do.
Yeah. And LEDs. Buttons and LEDs.
Are you still teaching your class? Do you have any classes coming up?
Yeah, I still teach the class. If you're interested, you can come up and talk to me and I'll give you the info. I'm not very good at marketing. I should probably have something up there about, but you can come see me if you want to learn how to make a robot.
You gonna run the table bot challenge for us in June?
Sure.
Yeah, very good.